Greg Crower-Hartman, otherwise known as Greg KH, is generally assumed to be second in command of the Linux kernel. For the past 12 or so years, has been maintainer of the Linux stable branch and the staging subsystem, has had his hand in a number of other subsystems being the maintainer or just generally developer on, and has been involved in the kernel for a considerably longer time than this, and has also been an author on a number of Linux-related books, Linux Device Drivers 3rd Edition, and Linux Kernel in a Nutshell. Basically, if there's someone you should take seriously in the kernel, and that someone is not Linus Torvalds, it's probably going to be Greg Crower-Hartman. And recently he held a talk at the OSS Summit Korea titled Rust and Linux, or Rust in the Linux Kernel. Why? This is a discussion which, even after all of these years of Rust being in the kernel, is still going on, and not just from people outside the kernel. Even kernel maintainers are still somewhat involved in this discussion. I'm not going to play the entire thing, I'll leave it linked down below if you want to check it out for yourself, but I will play some snippets that I think are important. Firstly, Greg begins by outlining that Linux is not suffering from a shortage of developers. If anything, it's the exact opposite of that.
It's a big community. Last year we had almost 5,000 developers, 350 different companies. Every release we have about 200 to 250 brand new developers. We have a problem of too many developers. It's a good problem to have. We're not complaining, but we do a lot of work. We have a lot of stuff.
Linux is one of these projects where it's so important, there's so many people involved in it, there's so many things that are built on Linux, that it's not in any position of, you know, just crashing out and dying anytime soon. For that to happen with a project this big, you'd need to see something really big happen, like, you know, Google, Amazon, Microsoft, and a bunch of others would have to come together and try to create something that directly competes with it, right? Linux, at least for now, nothing like that is gonna happen. Also, it's just vastly cheaper to work on Linux kernel because you don't need to worry about every little thing. Other companies are all relying on this same project, volunteers are working on stuff, all of these people are working on the same project, so you can just improve the thing you want to improve and not have to worry about file systems and memory management and all of this other stuff that everyone's gonna need anyway. Now, a lot of changes come through the kernel every single year, and the CVE number we see here is a little bit misleading. It says 13 a day. Basically, everything in the kernel gets labeled as a CVE because anything that goes wrong at the kernel level with a monolithic kernel can bring the kernel down. And if you bring the kernel down, you bring the entire system down. So technically, it's a security issue, it's a denial of service issue, so I do think they label way too many things as a CVE and kind of make the CVE system not very valuable, but that's the way they do it. And it's a really big deal that a lot of changes are made to Linux because, as a lot of you probably know, Linux runs the world. Even though Linux is not the main thing on the desktop, so many of the devices you interact with, even if you don't use Linux directly, are a Linux-powered device. Whether you have an Android phone, when you interact with a website, it's most likely running on a Linux server. Maybe it's running on Azure, Windows nonsense, but it's probably running on a Linux server. So many things out there. Everything, random embedded devices, powered by Linux. The stereo in your car, very likely powered by Linux. And because of this, it is very important this code is good, safe, sound, and actually doing what you expect it to be doing. A lot of the world relies on this code being good. So here is an example bit of code that is buggy. This is written in C and is from the kernel Bluetooth stack. Now, the problem here is this P right here can sometimes be null. So if you go and dereference P, well, bad things are going to happen because you're dereferencing a null and you're just going to crash the kernel. To fix this, a simple guard clause was added. If P is null, set the error, and then goto unlock. In the kernel, gotos are very common. I know there's lots of discourse about gotos at the kernel level. It makes sense. We're not getting into gotos today. That's a whole separate video. Basically, unlock is going and cleaning up some resources that are related to this, and because this could crash the kernel, it was labeled with a CVE. This talk is actually from last year, even though it was uploaded about a week ago. This change fixed the issue, and then everyone went about their day. Now here we have another example of buggy code, or at least a patch that is fixing buggy code. In this case, it is doing the check correctly, making sure that this is a valid value. The issue, though, is it's not going to the right location. Instead, it was returning the error when what it should have been doing is doing a goto to fail remove to clean up some resources. Now, in both these cases, you may call this a skill issue. You might say, just write better code and this won't be a problem. Just stop making mistakes. You're a C developer in the kernel. How are you making such basic mistakes like this? You shouldn't be in the kernel. You should stop being a developer. And you know what? You might be onto something, because modern versions of C actually have a thing called auto unwinding that make it so you don't have to do these weird cleanup things that traditionally you would have to do in C.
Here's an example of that. So the red code is stuff we've removed, green is what we've added. So instead of keeping the state, we can just say guard the code below this, and then when it returns, it'll clean things up properly for us. This is good. This is good stuff in the kernel. I don't recommend going and cleaning up the kernel with this because it gets annoying people, but all new code in the kernel should be written like this.
Another reason why he doesn't recommend rewriting everything like this is when you go and blindly refactor things, you're gonna introduce bugs, right? Like, anytime you make a change like this, it's a good change. It's probably a good change if you do it correctly, but you need to do it intentionally so you don't actually cause something else to break. Here is another example of allocating some memory and then having it automatically be cleaned up upon exiting the block. This is good, this makes things cleaner, this makes things better. This makes it so the computer is worrying about things that the user shouldn't have to deal with. This overall makes the code smaller, which means less chance for there to be problems. It makes it simpler to review, it makes it easier, there's less bugs, and also just makes it more fun. Nobody wants to be chasing down bugs in code they think is correct. And because they don't have a shortage of developers, there is a bottleneck when it comes to reviewing code. Reviewing code is a lot harder than writing code, especially when you're reviewing other people's code. You don't necessarily know exactly how they're approaching a problem, or reviewing your own code and you think the problem is correct because you wrote it, trying to understand what you did wrong with something, and if you did something wrong, it's difficult to separate yourself from the code because you've already thought out the problem and you're not going to submit something you know is wrong, so knowing why it's wrong is very difficult. Now back to the buggy C code from earlier. This is the same code written in Rust, and it's basically the same thing. There's a few syntax differences, but the important distinction is this question mark right here. This is basically saying, if this returns an error, exit out, there is something wrong here. Don't proceed any further.
And if you don't put that question mark in there, the compiler will complain and not build. And that's the key. Rust lets us express things in code that if the code is wrong, it just won't compile. So
which means you, as the developer, immediately know it's wrong.
if me as a maintainer gets a patch from you and written in Rust and it compiles properly, you did the logic right. And
Obviously, you can still make logic errors in Rust. What he's saying is you're not mishandling a value that is coming from a thing like this. You're not randomly just including an error value when an error value shouldn't be possible.
that saves me reviewing time and it makes things easier.
That's the important thing. Again, there is a bottleneck on reviewers. There is not a bottleneck on changes. There would be a lot more changes brought into the kernel if they had more people reviewing code. They just have so many developers, and it's increasing every single time that you just cannot keep up with the number of changes when you have to deal with patches where it might be broken in a way that another tool would not be possible to include that same breakage. And the same thing applies to a lock. The only way to get access to this data is by grabbing the lock, Otherwise, the compiler is going to complain. And if the compiler is complaining, you immediately know you've done something wrong.
And by doing that, when you're done with the data, it'll free the lock. That, again, is enforcing a pattern in the compiler, in the code itself, making it easier for us to do stuff. Between those two things, checking error values and handling lock properly and three things, resource stuff, that I'm guessing, I say, is about 60% of all the security bugs in the kernel. Somebody told me I was wrong, and they think that's about 80%.
And remember, Greg isn't just some random person talking here. Greg is kind of the security guy. Like, he is very deeply involved in that part of the kernel. Back to this slide. That is a lot of wasted time when you have to deal with all of these changes and you don't know if they're actually handling that data correctly. You are going to let things slip through and you're going to have to deal with those problems. And that is a ton of wasted time nobody wants to deal with. Rust can make reviewing code easier, enforce validation of untrusted data, enforce memory lifetime rules, enforce locking rules, enforce error handling, and enforce type safety. Now, you can say, oh, I want to have kernel rules that outline how to handle data in C. And they have that. They have kernel documentation. They have all of this good stuff that explains how to handle things within the kernel, to do things in a safe way. They have code style guides. All of this stuff any sensible project should have. But people make mistakes and reviewers miss things. And if you can eliminate an entire class of bugs that is the majority of your security bugs in the kernel, from a security perspective, that seems like a no-brainer. However, it's not without its flaws, and this is just inherent to doing programming.
But Rust is not a silver bullet. It's not going to just save all our bugs. Everybody says it's memory safe. Well, memory safe is interesting. Memory safe means if you do something wrong, your code will just crash, which in the kernel is not good. It's still CVE. So here's some code that you can write, C code, crash wonderfully.
For anyone who's not a programmer, what it's doing is accessing data after the end of an array.
It's a logic error. See, Rust, this is Rust code. If you access this thing, I'm going to run off the end of an array. Rust will check that, catch that at runtime, and go, you know what was going on, crash, you're gone. And that's good. At least we're crashing. We're not accessing memory in an illegal way that would allow you to have a security vulnerability. Rebooting the machine is still a vulnerability. It's still a denial of service, but it's not a bad one. So
it's a issue where rather than continuing to run in an error state, when there is an error, it dies. And when you're dealing with memory safety, when you don't want things to be able to do, arbitrary code injections, read off the end of arrays, access data they shouldn't be able to access, crashing when this happens is a better thing to do. Obviously, it's not good, and you don't want the kernel to crash, but crashing is better than running in that state. Now, none of this is suggesting something that hasn't been tried before. Today, there is 35 million lines of C code in the kernel, roughly 65,000 lines in Rust. That doesn't mean you're running all of that on your system. A lot of this is for hardware that you're not using. It's random legacy nonsense. It's ARM. It's RISC-V. It's GPUs that you're not using. It's Wi-Fi chips for the PS3. Things, obviously, you don't have in your system. So the average computer runs about 2 million lines of that on their system. A server is a bit less because a server is generally a much simpler system, and a phone is about double a desktop at about 3.5 to 4 million lines of code. And do you want a real-world example of something in the kernel right now that is written in Rust? So, are you aware of the kernel blue screen thing? I guess this one is black, sometimes it's blue. They've changed it a number of times. When you have a kernel panic, there is going to be a QR code that appears. This is in Rust. This is in Rust. This is something that is in your kernel right now that is Rust. I think the space that has most picked up Rust development in the kernel is the GPU driver space. There is a lot of new drivers being written in Rust, old drivers being ported over to Rust, because for graphics, It just seems like a better way to handle things. Another thing that I recently discussed on this channel is the binder driver from Google. This is very involved in Android. It's not something you're running usually on your regular desktop. Technically, it's not a Google project. It's just Google is the only consumer of it, so it is in the upstream kernel. But this was recently rewritten into Rust.
Change, you guys have seen people complaining about Rust. Change is hard. But if we don't change, we will not succeed because the world keeps changing. And that's okay. Not everybody has to convert. We're not going to write new existing code today in the kernel. We're not going to rewrite it in Rust.
If people want to do so, they can do it, but there's not just going to be this mass rewrite that's going to be forced upon people.
But new stuff can do it. We get offer the opportunity to do this stuff. And that's good. If we don't change, we won't succeed. But Rust also lets us reevaluate the C code. And that's good. Our APIs sometimes are really hard to use. Like I talked in the beginning, you look at code that's been there like, what? Who wrote this? This is horrible. Oh, I wrote this. Well, you learn over time that your APIs were wrong. Rust lets us revisit that and rewrite the APIs. If Rust were to disappear today, our C code is better for it. They've made us reevaluate a number of our APIs and rewrite things. Fix things up, make things more secure, make things more easy to use.
Because if you want to interact with the C code from Rust, there's some assumptions that need to be sort of properly ironed out. You can't just have things work as haphazardly as they did. By introducing a language like Rust, it forces you to actually do things in a more correct way.
And it can make, I, as a maintainer, am very happy to see this. It makes my life much, much easier. It can make it easy to, if it builds, it's going to work for the most part. That's a very big hurdle that C doesn't have in places.
And if you can introduce a way where you don't have to worry about as much of the code, you can introduce more changes into the kernel. You can make more improvements to the kernel because you're not wasting as much time dealing with nonsense.
Make the compiler do the work, and that's the key. We have the tools. Let's rely on those. So it makes Rust more fun for maintainers. And I'm very happy to see that. And it makes it more secure for Linux and for users. And that's more important for you guys. And that's great. And as always, world domination is proceeding perfectly. Thank you.
I am so happy you included that part. I'm so happy you included that part. And at the same event, Linus Torvalds also spoke on the matter.
But having been around for so long with tens, hundreds of maintainers that have been around for decades by now, people kind of get stuck in a rut, and sometimes you want to shake things up and say, hey, we're going to try this new thing, and I'm the person who says, okay, we'll go ahead. And
Look at this dude down here.
I'm giving Rust as an example of that, even though we've been doing Rust now for, 5 years, so it's not exactly new, but it was something where I felt that the kernel shouldn't stagnate, and we needed to do something new and bring in new people. So that's one thing that has changed for me, is that I actually feel like sometimes I need to encourage some of the other maintainers to be more open to new ideas.
Yeah, Rust was exactly one of the examples I was going for. And one of the things that I've noticed is that even though it's been around now for 5 years and with actual code in the kernel maybe for 3, it certainly created some noise. We had people express their frustration. There have been arguments about the formatting. There have been arguments about reviewing code that isn't in your language that you're comfortable with. We even had maintainers step down over this. So is it worth it? Is the introduction of new technologies worth the disruption to our processes?
I think it's worth it, but I also think that, yes, Rust has generated a lot of press, maybe, because it's a very visible part of the kernel. And I mean, Rust is obviously visible in other areas too. But at the same time, I mean, we have disagreements in pretty much every area of the kernel. It's part of the process of doing new development and finding bugs, and people sometimes get quite animated when they want to make their point heard. And I don't think Rust in that sense has been all that different from many other areas. It's just that it maybe gathered some more news. we're finally at the point, I think maybe Greg will talk about that, who knows, he follows that more
I think this talk may have happened before Greg's talk. I'm not sure.
than I do, where Rust is actually becoming a real part of the kernel instead of being this experimental thing. But it did take longer than I was expecting, certainly.
Yeah, so, and I mean,
Isn't it nice to hear someone just have a calm and leveled take about Rust? It's like, we want to experiment with this. We want to see what this can improve. Let's just go forward with it, and if it works, it works. If it doesn't, it doesn't, and we'll move on from there, basically. This talk isn't just about Rust, but I will leave it linked down below as well. I do highly recommend you go and check it out. It's always nice to see Linus and Dirk talking it out. There's lots of fun things that always come from these talks. The discussion of Rust in the kernel is not going to die down anytime soon. This is going to be something where, honestly, I expect 10 years from now, we're still going to be talking about it. Like we did with Pulse Audio. Is my camera not focused? Whatever, the video's ending now. Like we do with System D. There's always going to be people arguing about this, but hopefully, regardless of the arguing, things improve in a good direction. This is how I try to focus my camera, by the way. Sometimes I turn it on and off and it focuses. It's not doing it right now. Okay, I'll just restart the camera. Anyway, let me know your thoughts down below, especially if you're a kernel developer, whether it's a very active developer or just a couple of patches here and there. Let me know what your thoughts are about bringing Rust into the kernel, and if you happen to be someone who is working on Rust in the kernel, how has that changed your workflow? Or if not Rust in the kernel, Rust in some other sort of project, and maybe not Rust, maybe bring in a language like Zig or Go or something else, and moving things away from entirely being C. I would love to know your thoughts. So let me know down below. If you like the video, go like the video. If you want to go subscribe, do that as well. And if you really like the video and you want to become one of these amazing people over here, check out the Patreon, Scribes, Daily Bearer Pay linked in the description down below. That's going to be it for me, and the fighting will never end.